Greetings, this is BlockPolitics.com and I'm your host, Mikado Hunt. I am the anchor man for Black America, a true servant of the ancestors, and this is what you hoped it wasn't. Another platform for the conscious to discuss politics, culture, music, religion, some of everything. You know what I'm talking about? Today's episode is Ancestry. We're going back to see who I truly am. My goal here is to give you the tools to do the same at home. When I say who I truly am, I mean we're doing the DNA test. We're going to go to GeneBase laboratories. We're going to do the paternal side of my family tree. So that's going to be step one. We're going to come back and do step two, where we're going to do the maternal, and we're going to put it all together. So this is episode 1, Ancestry Project, BlockPolitics.com. Holla at your boy Mikado. Okay, this is the DNA Ancestry Project, and this is what it looks like. Alright, now we're back, and what we're going to do is we're going to go ahead and start it. This is the Ancestry Project. It's a participation kit. It comes in 3 easy steps. The first one, this kit contains everything you need to collect the DNA sample quickly and painlessly using the mouth swab. Number 2, once the laboratory receives the sample, testing begins immediately. Number 3, log into the GeneBase. So we're going to go ahead and check this out. Alright? Might as well walk with me. Let's go. Check him out. Let's go. Alright. Alright. I got the kit, the Ancestry kit. I've taken the contents out. Looks like I have to open this up and get ready for it. I guess it'll give me instructions. So see what happens. Okay, I take it this is what I send it back in. Let's see. Alright, step 1. Complete the client information and consent form located on the flap of the specimen envelope. Alright, I see that. Wash and dry hands thoroughly. Carefully peel apart the sleeve containing a sterile swab. Remove the swab carefully, holding the swab by the stick. Scrape and rotate the swab vigorously inside the right cheek, approximately of the individual, for 15 seconds. Step 5. Immediately after collecting the cheek cells, place the swab directly into the specimen envelope. Okay. We're going to put it straight inside the thing. It says leave open for 30 minutes and let it air dry. So we're going to go do that. So I'll follow you. Let's go. So we're going to let it dry. Alright? I'm here next to my laptop. Let it dry. Alright, so we got the mouth swab part down, and it also said that we need to log in on the GeneBase. So let's go ahead and do that. Okay, so now we have everything logged into the GeneBase. Our profile is official. Now it seems all we have to do is wait for them to come back with our results. So that's what we'll wait for. But in the meanwhile, I think it's good for us to go over exactly how does DNA work? How are they able to trace me or you back to our ancestors? So let's check it out.
DNA consists of two intertwining strands, which are basically joined up chemicals called nucleotides. Just 4 different types of nucleotide are found on each strand: adenine, thymine, cytosine and guanine. To glue the two strands together, adenine always pairs with thymine and cytosine always pairs with guanine. That's just the nature of their chemical bonds. When DNA copies itself, the copies aren't always perfect. So if the wrong nucleotide gets copied, the two strands won't join up at that particular point. You've got yourself a marker. If the marker is on mitochondrial DNA, that marker will be passed down through every female descendant without alteration. If it's on Y chromosome DNA, it'll be passed down through every male descendant without alteration. So if we find a marker in people today, we can trace it back through thousands of generations to find out when and where it started. Now imagine if all these people were migrating. This group stays put, this group moves north, and in this group, headed east, a baby boy is born with a unique marker on his Y chromosome. The baby grows up and has male children who also carry the same marker. As the group continues its migration, some tribes settle and others keep moving eastwards. Like a leaky boat, the movement leaves in its wake a trail of descendants with the red genetic marker. So by checking the DNA of people living today, we find those with the same genetic markers. This map shows the distribution of men with a marker on their Y chromosome called N130. We can wind this film backwards and follow the migration route they took, which was the first complete one out of Africa around 60,000 years ago. That was the basis for the study conducted by Spencer Wells and others in 2000, which involved collecting DNA samples from indigenous people all over the world. Wells found distinctive genetic markers and traced each back to its source, marked here by red circles. We're retracing the migration paths our ancestors took backwards through time, and this is where they started, once again in Africa. Because the mutations happen at a fairly regular rate, these ancestral markers can even be dated, so the timescale on this map marks the progress of each migration. Populations that stay put and don't migrate will, of course, have a lot more of these genetic markers, so it's not surprising that we find the greatest genetic diversity in Africa.